So I will be talking about increasing and decreasing functions, and this is section 3, and I'm skipping section 2 because I'll talk about the mean value theorem later. So increasing and decreasing functions. What we're going to do is we're going to use the second derivative to determine whether it's increasing or decreasing, just to see whether it's maximum or minimum, or if it's just a different point. So generally, these are the guidelines, and the function has to be continuous and the closed interval and differentiable when we're using the second derivative, and when we the first. And we have the first derivative and it's greater than 0 for all the x's that we put in, its function is increasing. And when we have the first derivative and it's less than 0, then the function is decreasing. And as stated before, when its first derivative is equal to 0, then it's just constant, and that's a critical point. So we're also going to talk about the first derivative. And remember that the first derivative is just about the slopes, and when we do that, when we use a first derivative test, we're just finding the derivative, we're setting it to 0, and then we're determining the signs by picking values on both sides, but we'll talk about that later. Okay, so this is number 3 of section 3. So, what they're asking us to do is identify whether it's increasing or decreasing in the intervals which it is. So first we just have to find the derivative. So now all we have to do is just find the 0. So we're going to set it to 0. So x equals 3. For this first question, they do give us a graph, so it's obvious what the critical point is, or what we learned before about extrema. And that's where the derivative is 0, is at x equals 3. But they want us to determine whether it's increasing or decreasing. And so what remember about the slope and the tangent line is that, that it's the tangent line is negative, it's decreasing as it comes in, and then it equals 0 right here, and then it slowly begins to increase as we go up on the right side. And we'll use x equals 3 as a reference point. We're using the critical points as a reference point for figuring out whether it's increasing or decreasing. So what we're going to do is we're just going to plug in values on each side of 3. So plug in 2. Minus 6 equals, and then we'll plug in 4. So what we figured it out is that on the left side of 3, it is negative. So we got negative 2 by plugging in 2. And what we determined on the right side is that it is positive. On right, positive. So we've figured out we're going to use these to determine whether it's increasing or decreasing. And just by using some knowledge, we're just gonna, and referencing this again, that when first derivative is greater than 0, its function's increasing. First derivative is less than, it's decreasing. So as we can see on the left, it is decreasing. So coming from the negative infinity, so we'll say coming from negative infinity, oh, that's an 8. Coming from negative infinity to 3, the function is decreasing because first derivative was negative. or less than 0. And then going from 3 to infinity, it is increasing because the first derivative was positive on the right. So that is number 3. Number 9. Okay, so they don't give us a graph this time, but we know how to do it. So what we're going to do is we're just going to find the first derivative, and to make it look easier, we'll go like that. 2, and then is equal to -2. Alright, so that is the first derivative. Now we got to find the zeros. This is just x equals 0. So that at 0 is a critical point, or something's happening, and it's an interesting point. And what we're going to do is just then plug in values on the right, values on the left, and determine where it's increasing and decreasing. So plug in -1, and we're plugging them back into the first derivative. And that is equal to 2. Then we plug in +1, which is on the right. This is equal to -2. So what we figured out is that it's positive on left, negative on right. So now we're able to figure out whether it's increasing. And remember that if first derivative is greater than 0, it's increasing. So on the right, it's greater. So coming from -infinity to 0, we're increasing. Going to 0 from to infinity, we're decreasing because it's negative values. So that's number 9. Number 10. So again, they're just asking us to find on the intervals which it is increasing and decreasing. So first we must determine the derivative. So what we're doing, we gotta do the quotient rule. Yep. And now we can simplify, and we get x over x to the second plus 2x over x plus 1. Now from this on we could simplify and figure out the zeros by writing it out, but sometimes that just gets too complicated, and all we're trying to do is figure out whether it's increasing or decreasing. So easiest thing to do is to just graph it and to understand where the zeros are of the slope. We're not going to graph the first function, we're trying to figure out the first function. We're graphing the second or first derivative. So by looking at the graph, just by looking at it, we can see just by eyeballing it, we can see that it's seems to be 0 at -2 and 0. So we're going to plug that into the graph to be sure. We don't want to be wrong here. So when we plug -2 in and 0, if we find out that it is equal to 0, those are the zeros of the graph. So just move on from there. So what do we do with these? We plug in values. Now we have 2 critical points, but we can still determine where it's decreasing and increasing. We just have to be wary of what we're plugging in. So we're going to plug in -3 because that's the far left value. So and this is equal to 3/4. So it's positive on the very far left, and now we want to plug in a value probably a little bit in between. So -1 looks like a good point. But we get 0 on the bottom. Now, what does this tell us? That it does not exist. There's no, like, well, I don't know about it doesn't exist, but that it does something funky at this point. We're not sure exactly what, but the slope is going off. So remember that when we plugged in the first derivative, and it went off to infinity at that point. So the function is doing something interesting. Is it necessarily a bad point to plug in? Not really, but it's going off to negative infinity. So when you come to this, it's best to plug in a new point. It could be like -1/2, and we could figure it out better in our brain. Have to use the other side. So when we do this, we get okay, sorry. So when we plug in -1/2, we get the answer -2. So we found out that on the right of -2, we're getting negative values, and it's also the left of 0. Now we're going to plug in something to the right of 0, so 1. It must be 1 squared plus 2 over 2 squared, so just 2 in the bottom. And we get 3/4, positive again. So what does this tell us? So this shows us that it's so we got 3/4 on the left of -2, so it's positive on L of -2, but then we got -2, so it's negative on right of -2. Then but that also goes for so I guess 0. But then on the right of 0, we got positive again. So we can determine that from infinity to, or negative infinity to -2, it is increasing. But then it's just negative in the middle. So from -2 to 0, it's decreasing. And then from 0 to infinity, it is simply increasing again. So that is what the slope of the function is doing. It's from -infinity to -2, it's increasing. From -2 to 0, it's decreasing, and it might be doing something else. And then from 0 to from 0 to infinity, positive infinity, it's increasing. So that is number 10. And number 17. Now they want us to actually use that first derivative that we showed at the very beginning. So just have this right here, and we'll reference it in a minute. So we're gonna start out as well as do. They give us like some idea, like for A we're supposed to figure out critical numbers, B and find the intervals, and C use the first derivative. We're just gonna do everything, but at the very end use what the first derivative tells us, and it'll tell us what if it's a maximum or minimum or neither. So we're just gonna find the derivative. So we get 2x plus minus 6, and we're just gonna set it equal to 0. And then we get x equals 3. So at x equals 3, that is a critical point, and so we're going to pick values in on both sides of it to find the sign and to use the first derivative test. So I guess that is a or something. But first we're going to talk about, so we can understand what the first derivative is showing us, we're going to still reference to whether it's increasing or decreasing. So let's pick 2. We'll get 2 equals 2. That's just -2. So for when we plug in 2, we get -2. We get a negative value. So then we can plug in 4, so it's on the right. So now we get a positive value. So remember what we talked about. So if it's the first derivative is showing negative values, then the function is decreasing. So from -infinity to 3, the function is decreasing, and that means from 3 to infinity, the function is increasing. So what does that mean in terms of the first derivative? Well, remember we talked about at the very beginning, or this sheet of paper I showed you, and it talked about how if we get signs of positive infinity, not positive, like when we plug the first derivative in and we get values, we get some values positive on the left and then negative on the right. That is showing signs of a maximum. If we get values that are negative on the left and then positive on the right, that's minimum. But if we get values both showing negative or both showing positive, it's neither maximum or minimum. So here we got values that were negative on the left, and we got positive on the right, or we could write it as they do. This is what we got. So if by using what we know about the first derivative, that means that it is a minimum. So this graph, the function, original function, if we graphed it, we would get a minimum. So that's number 17. Number 26. So again, let's just find the first derivative. It is 4x to the third minus 32. I'm going to set it to 0. And then divide by 4. Take that and we get x equals 2. That is our critical point. And it could be, I do believe, positive or negative. Just make sure that I'm not misspeaking. Yeah. So, yeah, that's really sloppy. So we get x equals 2. just want to make sure I'm doing the right stuff. Okay, so it's not positive or negative, it's just x equals 2. So now we're going to plug values on each side to figure it out. So we'll plug in 1, and we're plugging them always into the first derivative. And we get negative 28. Plug it on the the right, and let's do 3. And we get 76. So we got positive on the left. Sorry, I misspoke. We have negative on the left, positive on the right. If we look at it in terms of decreasing and increasing, that values are negative, which means it's decreasing. So from negative infinity to 2, the function is decreasing because we got negative values. But from 2 to infinity, it is increasing because we got positive values. So if we look at it in terms of the first derivative test, we are getting negative, then positive. And negative and positive shows us that the function is a minimum. So that is number 26. I hope this helped you.